Friends, welcome to the first lecture for the MDM subject Introduction to 3D Printing Technologies. I am Dr. Vipin B. Gawande, Assistant Professor in Department of Mechanical Engineering. Now, this is the syllabus for our MDM subject. So, for the subject, the in for activity there are 20 marks are there. For in-sim examination 20 marks, and for in-sim examination it is 50 marks. Okay, and there is 20 term work for the 20 marks. Total 110 marks are there for this subject, for the credit of 3. So for this the subjects, we have the certain prerequisites and the objectives that are mentioned here. Okay, so these are the course outcomes for the subject. So for we have 4 units, and for 4 units we have the 4 course outcomes. This is the first unit, Introduction to 3D Printing, and we will deal with this in this current lecture. So these are the guidelines for the term works. There are total 8 practicals are there, and the the PDF for the term works, it is already uploaded on the Google Classroom. For guidelines for the activity, to you have to select a certain problem statement, and for that problem statement you have to design, you have to develop the 3D model, and then you have to assign the parameters in the 3D printing software. We have also conducted the industrial visit for this subject. Now let us start with the subject. So what is 3D printing? So we all know that the conventional 3D printing is there. So for in conventional 3D printings, we write something on the desktop or the laptop, and then it is printed in the form of the 2D text. So that is a conventional 2D printing. Now imagine that we have the 3D model in our we have imagine a 3D model, and we want to print that 3D model. So okay, so there is a printer is there, so that is called the 3D printer, and using this 3D printer we can directly print a 3D model. So 3D printer, it is also known as additive manufacturing, and it is a process of creating three-dimensional objects by layering material according to the digital model. Okay, why this is called as additive manufacturing? We'll see this. Now, the additive manufacturing means what? The additive manufacturing means in the manufacturing in which the material is added layer by layer. If you take the concept of this the pyramid, so to form this pyramid, initially the base is formed, and then the second layer, third layer, and then it goes to the top. Okay, in the same way the additive manufacturing it works. Okay, so that means it forms the complete model by forming layers and layer by layer. This is the history regarding regarding the 3D printing. So in 1980, the first rapid prototyping system was developed by Dr. Kodama of Japan. Then in 1986, Chuck Hull printed the furniture parts using the photosensitive resin layer by layer, and this method is called as stereolithography. We will see this in detail in the coming lecture. So the Chuck Hull, it is called as the father of this 3D printing, and afterwards, in the consequent years, the Chuck Hull has formed its own company that is called the 3D System, and uh, they have promoted the first commercial SLA printer. Okay, stereolithography printer. Then in the coming years, there is more advancement in this the technology of this 3D printing, and now we are in 2024. We have now more advanced 3D printers with us. So this is the patent filed by the Chuck Hull through his 3D system company. So this is the 3D system company which is formed by the Chuck Hull, and this is the first 3D printer that is developed by the 3D system company. So this is the SLA printer. Okay. So let us see the definition of this additive manufacturing. So I already explained you this is the method in which the object is built by adding material layer by layer. While in subtractive manufacturing, which is on your right, so we have to remove the material, and this is called as the subtractive manufacturing. Okay, so what are the the advantages and disadvantages with respect to the traditional methods and the additive manufacturing. So in 3D printing, the process is what we are adding the material layer by layer. While in case of the substitute manufacturing, we have to remove the material from the given the initial material. Okay. Second, material efficacy. If you see in case of 3D printing, the material wastage is very less because here we are taking initially material and then we are adding this material, so the wastage is very less. While in case of this, the substitute manufacturing or the traditional method, we are removing the material, so there is a huge wastage of material is there. In case of complexity and the design freedom, so in 3D printing, using the 3D printing, we can create very high complex geometries, which would be difficult to impossible, which would be difficult or impossible to achieve with the substitute methods. So highly complicated geometries or the models can be created using 3D printing. While in traditional methods, though we can create the complex geometries, but the internal features are very often challenging or impossible to create in case of this traditional method, and there is the limitations are there for creating the complex geometries in case of the traditional methods. Customization and prototyping. In case of this, the 3D printing, the designer can change the geometry frequently, which is not possible in case of the traditional methods. So it offers the customization, and we can create a number of parts, that is, we can create a number of prototypes in 3D printing. So okay, that is very easy. While in case of in the traditional method, it is not possible because every time you have to create the molds and we have to form the we have to develop the material. So that is not possible in case of the traditional methods. So customization, so very easy for the change in design. We can change the design frequently, and we can form a number of prototypes in case using the 3D printing. Production speed. Now, in this case, the 3D printing, it is a very slow process. It takes sufficient time to form the model, or that depends on the complexity of the model. While traditional method, it is very fast. The manufacturing methods, so we can create a high volume of the product the parts using this traditional method. Okay, so that is not possible in 3D printing. So in production speed, definitely traditional method is superior than the 3D printing. Now, in cost consideration, if you consider the cost consideration, the 3D printing for the low volume production, custom parts and prototyping, the 3D printing, it is very effective. And while in case of this the traditional methods, if you are manufacturing large scale production, so the cost per parts will be less. Okay, so if you see here, so traditional methods, the in traditional method, if you are getting large volume, so then the cost will be less. While in case of this, the if you are creating the large number of parts using this traditional method, so this is the blue graph for the traditional manufacturing. So then the cost will be less. If you are creating the less number of parts, so for traditional manufacturing, the cost will be very high. But for 3D printing, even if you are producing the less number of parts, the cost per unit part will be less, and the same thing will be for the high volume of the productions also. So so for cost consideration, the 3D printing is very superior as compared to the traditional methods. Then material availability. So for 3D printing, large range of the materials is available. For traditional methods also, the large number of which are available, but the material is very costly in case of the traditional method as compared to the 3D printing. Surface finish and precision. So in case of 3D printing, the surface finish is very superior. We need to do certain post processing for the parts that are developed on the 3D printing, and we'll get the required surface finish and the precision. In traditional methods also, the post processing is required, but it is certain costly. Okay, and if in case the materials suppose the material doesn't meet the required dimensions, so then we have to change the parts and we have to again repeat the same process. So it is not the that means it is not cost effective process. Traditional method is not a cost effective process. While here in 3D printing we can easily replace that parts with the second print. Environment impact has uh, it is said that the for 3D printing, whatever the materials which are which we are using, we can reuse the material, the wastage, the material that is formed in the 3D printing, that can be easily used, that can be easily reused. Okay, uh, and the new material can be formed. While in case of the traditional method, the wastage of material, whatever the material get wasted, so we can't create the new material here, or it is a very costly matter. Applications in 3D printing, there are huge number of applications are there. It can be used in medical implants, aerospace components, art and design, small scale manufacturing, prototyping. Okay, so all these are the applications of the 3D printing. The traditional method is also having, because we are using this traditional method from a long time, so it is also having the having a huge applications in aerospace components, industrial machinery, consumer in electronics, uh, and any applications requiring high volume productions or of identical parts. So high volume production, it is a biggest advantage of traditional method, while low volume productions, we can do it using the 3D printing. These are certain advantages of 3D printing technologies. Customization, so we can easily change the or use or as per the requirements of the customer, we can design the model and we can easily create that within no time. Rapid prototyping, so it is very easy. We can quickly create prototypes to test form, fit and function. So initial level of the designs we can quickly do using this rapid prototyping. Cost effective for small production, so that I already explained. Any type of the complex geometries can be printed using the 3D printing. In 3D printing, the materials wastage is very less. On demand production, so the products can be printed on demand. And it doesn't require any inventories. Okay, uh, and the production is very easy. Supply chain simplification, so we don't have to follow the centralized supply chains here, because here it is very simple. Just design your 3D model, apply the parameters to it, and then print it. Okay, so we don't have to follow the long supply chain managements here in case of the 3D printing. Disadvantages are limited material options. So though now the materials are available for the 3D printing, so the technology is taking it is growing now. And it is developing. So but still the limitations are there for the 3D printing as compared to the traditional methods. Surface finish and quality. It depends on how you are assigning the parameters to the 3D printer and the quality of the 3D printer you are purchasing. Okay, so that is the surface finish and the quality. Slow production speed is the 3D printing. It is generally slow as compared to traditional methods, making it less suitable for the mass production. Okay, for the that is the low production or low volume productions, we can use the 3D printing effectively. Size limitation. The size limited, the build size of the 3D printer is limited. When we are purchasing the 3D printer, so the size of the 3D model, it can be decided based on the we have to decide how much the size of the 3D model based on the build size of the 3D printer. So we can't print a large models using the 3D printer. Okay, so that is a disadvantage of the size limitations for the 3D printer. Initially, 3D printers are 3D printers are cost effective. Initially, the 3D printers are very costly. For the that means the materials like metals, resins like this. Okay, the FDM printers are as compared to the other printers, they are very cheap. Okay, so high initial cost, it is again the disadvantage of the 3D printing. Intellectual property concern, so we can easily copy any type of material using this or we can print this using the this 3D printing. So there is a concern regarding the intellectual property. Limited strength and durability. Now this is the whenever we are printing something on the 3D printer, so we have to concern about the strength and durability. So you have to do the initial analysis regarding that one, and accordingly you have to assign the parameters to the 3D printer. So a little bit experience or the knowledge of this the design knowledge is required for the before printing any 3D model using the 3D printer. These are some of the applications of the 3D printing. So the total card is printed using the 3D printer. Now at IIT Kanpur, they have totally built the post office using this 3D printer. Then we can build using metal printer. We can build the engine blocks for medical implants. The 3D printer can be used using the material that is supported by our body. In aerospace, now we can print the total the aeroplane or the aerospace parts. So that is possible using this 3D printer. And in art and design also, the 3D printer can be used. So this is the video representing how the 3D printer can be used to build a house. Okay. Now, now let us discuss about the different parts of the 3D printer. So 3D printer, now it looks like something like this. This is the basic design of the 3D printer. Now each 3D printer, it is having the frame, then it is having the extruder. Now this extruder part is very important. We have the filament. So this is called the filament. The filament, it comes in the form of the wire having the diameter of 1.75. Now this wire, it comes through this extruder. Okay, so let me show you this one. So this filament, so like this. So filament, it comes through this extruder. So extruder, it is having one servo motor. So it takes that the extruder, it pulls that the filament, and then it goes to the nozzle. Okay, so here this is a nozzle. The nozzle in this the part, we have the heater. So here we have heater here. Okay, here heater. So we have to provide the temperature to this heater. When we provide the temperature to the heater, then this filament get heated, and that filament comes on the print bed. Okay. So since we are using the heater, we have the cooling fan here. Okay, and the nozzle is also provided. Okay, so nozzle, the filament comes through this nozzle. The nozzle is having the various temperature. So sorry, the nozzle is having the specific diameter. So it ranges from 0.4 mm to the other diameters. We have the power supply for this one, SMPS. We have printer bed. So this is called the platform or printer bed. It is also called as platform or print bed or printer bed. Then we have the motherboard where all the programs are there. The programs are assembled. We have display system, so it may be manual or it may be the touch screen. Okay, so these are the different parts of your 3D printer. Okay. Okay. So now all these parts are explained here. So frame, then the print bed, extruder. So when the that filament is there, okay, so the extruder, it pulls that the filament, and then it goes to the nozzle. It is having the two parts. One is the cold in, and another one is the hot end. In a hot end, we have the heater, and the cold end, it pulls the filament and feeds it to the hot end. So that is the two parts are there. One servo motor is there. So this is the servo motor here. Okay, on this servo motor, this hop gear and idler gear is there. So when the spring the servo motor, it rotates, so this hop gears and idler gear, it pulls the filament, and then it passes through the nozzle. Okay, then we have the cold end. Here this is the cold end, which pulls the filament and supply it to the nozzle. In the hot end, we have the heat sink, we have cooling fan, we have heat break, and then we have the heater. So we have to supply the temperature to the heater. So suppose if we are using the PLA as a material, then the temperature is 220 degrees Celsius. So when we supply this 220 degrees Celsius for this particular heater, the filament get heated. because of this, the heating of the filament, the heat it flows above, okay, over in the heat sink, and then it is dissipated in the environment. So cooling fan, it allows this hot air to get dissipated into the atmosphere. Okay, for that purpose, the cooling fan is used, and the heat sink it helps to remove this the hot air from the hot air which is coming from the heater to the environment. Okay. Then we have the stepper motors. So these stepper motors are since we are calling this as a the 3D printer. So the three motors are used for the movement of x-axis, y-axis, and z-axis, and the one motor is there in the extruder. So total four the stepper motors are there. Three for the movement in the direction of x, y, and z-axis, and one is for the one in the extruder. Then we have the belt and pulleys for the stepper motor. It is connected with the belt and pulleys for the movement of for the movement of the bed and the nozzle assembly in X, Y, and Z direction. Then we have the lead screws. So the lead screw used to control the vertical movement of the vertical movement, that is Z axis of the print bed. So lead screw that is used for only for the movement of this bed is Z axis. Okay, something like this. Then we have the control board. Now this is the brain of the computer. It controls the motor, heating element, and other component based on the instruction from the 3D printing software. We have power supply. It provides the power to all the electrical components of the printer, including control board, motors, and the heating elements. Then we have the filaments, the material used for printing. Typically, the use for the printing, so it is available in various forms like PLA, polylactic acid, ABS, PETG. We will see the different types of materials in unit number 4. The filaments can be made from the other materials like nylon, wood, and metal. Okay, metal plastics. So this the filament comes in the form of the spool. One spool is of 1 kg, and the cost of this spool is about 1,000 rupees. Okay. Then we have the end stop and sensors. These are the end stop. During the movement of this bed and the nozzle. So we have the stops here. End stops are there. Uh, so it helps us to limit the limit of the printer movement. To sense this movement, limit of the printer movement, we have the sensor. So we call this as end stops. Then after that, we have the LCD screen. So that is for the user interface. We can control the printer start, stop, prints, and setting directly using from the printer without needing the connected computer. So everything is here on the printer. So it is either manual or the we can use the touch screen. Okay. So all types of the parameters can be set using this LCD screen. Okay. So these are the major components. So all these are shown here. These components we have used when we have developed our own 3D printer in 2019, and then finally we have developed our 3D printer. Okay, so this is our first printer. So this is developed by the first year students in 2019. 1920. So we have developed, this is the first part. This is part of the 3D benchy. One type of the 3D model which is used for the calibration of the 3D printer. And then these students have in first year they have developed this. They have started developing this 3D printer, and then in second year they have started their own startup. Okay, so these are the two students are there, and I have guided these students for the development of this 3D printer. We have presented this in various the competitions. Okay, so this is the final product. Okay, so in Krushik also we have demonstrated that one to various dignitaries like Honorable Rohit Pawar, then Honorable Sahib, okay, ex-chancellor Symbiosis Padma Shri, Padma Bhushan, Dr. S.B. Muzumdar. Then also we have presented this product in at IIT Kanpur in the startup competition, and we got the consolation prize for this product. So this is the award certificate from the IIT Kanpur. Okay. Now, what will be the steps for the 3D printing? So let us see this one. Okay. So the steps for the 3D printing. So 3D printing, it is completed in the 3 steps. First of all, we have to develop the 3D object. Then in the second step, we have to take it into the 3D printing software. So the second step, this one. So this is the combined second step, and then finally we have to take it to the printer. So in 3 steps only we can print any 3D model using 3D printer. Now this is the first step. Build a model using the 3D modeling software. So for this, to develop the 3D model, you can use the various 3D modeling software like Vision 360, CATIA, Solid Edge, ANSYS, or any type of the 3D modeling software you can use. Or you can take the ready-made 3D models from the internet. Thingiverse is a website where from here you can take the ready-made 3D model files for your 3D printers for developing 3D models. Second second step is the software. You have to take it to the 3D printer software where we have to do the slicing. What is meant by slicing? Now, just imagine you are cutting the onions slices, and then afterwards you arrange the slices one or other, and then you'll get a total onion. The same thing is there. So this is the first layer, second layer. So this is called the slicing of slicing. Okay. So same thing in the 3D modeling software, we divide our model into slices. So we will cut it into number of slices. We call it as a layers also, and then our 3D printer forms the same layers, and our product get formed. So here now once you have generated the model in the 3D printing software, you assign certain parameters in the 3D modeling software, and then export that model to the 3D printer. So the last part is your 3D printer. Now your 3D printer will start printing the model using this G code that we have generated in the 3D printing software. Okay. Now, what will be the applications? So the major applications are in educations, electronics, automotive, medical, architectures, and aerospace. Now, what will happen if since we are getting the wastage of material in case of these 3D printers, we can recycle it. We can form again the filaments, and we can develop the we can again develop the 3D printed parts using that recycled filaments. So we have worked with these recycled filaments. We have generated the the filament using this wastage filament, and then we have presented that paper at the IIT Patna. So these are the students associated with me, and we have we have completed this project. Okay, so we are also offering the summer internship to the students on this printer. Okay, now